Good afternoon, everyone. Dr. Stillman here with another Monday Masterclass. And today we are going to be talking about a very, very important topic for all of you to wrap your minds around and do a little bit of critical thinking on. And that is, how much do you know, or how do you know how much of a nutrient you actually need, right? So this is basically, I don't know, 50% of my job is to help people figure out the answer to this question. But I think it's very important to understand the context behind the question before you try to answer it, because a lot of people won't start with the 50,000-foot view, and they end up making mistakes and errors in thinking that lead them to waste time, waste money, and sometimes actually harm themselves unwittingly, which I see all the time. Before I jump into the topic, I want to let you all know that this is a Monday Masterclass. If you would like updates on these, you can go to stillmanmd.substack.com and sign up. You will get an email with a link to the video as it's hosted over on YouTube. You can also go over to YouTube, like, comment, all that stuff. Turn on the notifications button, watch these live. They're about 3 o'clock every Monday. I am also planning on, for the premium subscribers watching this, discontinuing the Q&A afterwards, because there are a lot of other Q&As I'm doing for various programs. And if you want to have access to me, I recommend that you join one of those programs, but more because I asked people what they wanted, and they mostly said, we want more of your protocols and recipes. So the protocols, recipes, and behind the scenes stuff is what I'm going to be adding more of to the premium subscription. And there will be one of those posts every week, as well as the masterclass, and that will be the schedule going forward. So without further ado, let's jump into Optimal Micronutrients Delay Mitochondrial Decay and Age-Associated Diseases by Bruce Ames. There's no reason for any of you to know who Bruce Ames is, but he's actually a really important figure, in my opinion, in the history of nutrition. So I first learned about Bruce Ames when I was in residency. He had done this really cool paper on something called triage theory several years before I got into residency, published in about 2007, 2006, and then he kept publishing into the last, I mean, he's still publishing as far as I can tell. But this paper was really important and really impactful. He was unpacking or really I would say studying a concept that was first put into the medical and nutritional literature by Linus Pauling, as far as I can tell. And that was that there's a big difference between the amount of a nutrient that you need in order to not die, which we would call an acute deficiency and severe deficiency, and the amount of nutrient that you need in order to live optimally. Why is this such an important concept, right? Because the whole world of nutritional supplementation is based upon the premise that you should take, or I'm not going to say that the whole world, but a lot of the narratives in marketing nutritional supplements, diets, you know, all these things that you hear about with regards to your nutrition is that you need more of it than you're getting in order to be optimal, right? Now, the problem there is, as you all know, there's a perverse incentive for people to sell you things that you don't need just because they make money on it, right? Which is why you intrinsically want to do some research and some thinking about a supplement before you go out and buy it. But I see people not doing this thinking properly or appropriately, and winding up on buckets of supplements that then either don't work for them or that actually cause harm. And I know that the harms of nutritional supplements are massively overblown. No one in their right mind debates that. But the reality is, a big part of what I do with people is I help make their supplement protocols more efficient and effective, which means we'll often pare down to 5 to 10 nutrients max. And that even includes hormones if we're using bioidentical hormones, many of which are over the counter, for the record, so that we're paring it down so that we get better outcomes, more impact for less money. Many people actually save the cost in supplements of what they're spending per month by becoming a patient at my medical practice or joining one of my programs. And the point of the Substack is actually to deliver some of that value behind that paywall in the protocols and recipes that I provide. But anyway, I really want to dive in today. We're only doing one paper today, and it's this paper by Bruce Ames where I talk about the background of this. And so he got into this research, published some great papers, and we're going to summarize those today. So this is from the abstract of the paper. So research on delay of the mitochondrial decay of aging by supplementing rats with lipoic acid and acetyl carnitine. Sorry, we're going to be reviewing that. We're going to review the triage theory, which posits that modest micronutrient deficiencies common in much of the human population accelerate molecular aging, including mitochondrial decay. And we're going to look at the finding that decreased enzyme binding constants, increased Km, for coenzymes or substrates can result from protein deformation and loss of function due to loss of membrane fluidity with age or to polymorphisms or mutation. Okay? Don't worry, there's not a test later. I'm going to break all this down, make it really simple and understandable so that you have the key concepts that you need in order to take this information and think for yourself out there in the wild, wacky world of nutritional supplements. Okay, so section number 1. This whole section is about the premise that lipoic acid and acetylcarnitine supplements decrease the mitochondrial decay of aging. So mitochondrial decay appears to be a major contributor to aging and its associated degenerative diseases, including cancer and neural decay. Okay. Translation: as your mitochondria, which are the powerhouses of the cell, for those of you who don't know, as they decay, you see, and as they decay more and more and more rapidly, you see what we call degenerative diseases. Every disease that you could not want to get, generally speaking, with the exception of rare genetic mutations that cause, problems like inborn errors of metabolism, is associated with mitochondrial decay, which means the name of the game in preventing disease and maintaining well-being is to optimize mitochondrial function. I don't think that's a controversial thing to say in the slightest. Many, many, many conventional scientists are looking at aging through this lens. And I think the ones who are not are hopelessly behind the times, sadly, because modern medicine tends to focus on drugs and surgeries. 99% of doctors have no earthly idea what's going on in this space. And that's why their patients are just circling the drain, as we say, in the doctor's lounge anyway. Sorry. Okay, oxidative damage to DNA, RNA, proteins, and mitochondrial membrane lipids contributes to this decay. Translation: when you get oxidative stress or too much oxidative stress, it can damage key elements of the cell, and that will then impair cell function, and this then damages mitochondria and causes what we know as aging and mitochondrial decay. This leads to the functional decline in mitochondria. Notice they say functional. This word is something, functional medicine has taken off in recent years as like a dominant buzzword in the branding of integrative, holistic, natural, whatever medicine. That's a whole nother story for another day. But at the end of the day, I want you guys to think, and the way I think about what I do is I'm primarily concerned with a patient's function. And if I can't help them function better, then frankly, I would pack up and go do something else, like be a hospitalist as I used to be. But the truth is we can help people to function a lot better. And we see this in vivo in the cell culture data. We see it in vivo in biochemical analyses as Bruce Ames and his colleagues have documented, right? So we want to prevent this functional decline in terms of the decline of the function of the mitochondria, their ability to generate energy, cells, tissues, and organs as well on the whole, right? And that's the name of the game really in anti-aging and regenerative, functional, holistic, natural medicine, okay? So as mitochondria, cells, tissues, organs decline, there's an accompanying loss of cognition and ambulatory activity, which is a fancy way of saying you get stupid and slow and weak as you get old. And this all is a part and parcel of the aging process, right? Decreased capacity to produce ATP and increased oxidant production are two properties of aging mitochondria supported by multiple lines of direct and indirect observation. Translation: as mitochondria lose their capacity to produce ATP and as oxidant production goes up, you see that the mitochondria themselves are aging and are becoming less and less efficient and therefore powerful. Now, I want you guys to know that there's a big problem on the nutrition side of the equation here, where, and when I say that, I mean the people in the nutritional sciences and metabolism and biochemistry and whatever, a lot of those people are not adequately up to speed on what's going on in the world of quantum biology. So Bruce Ames is, and maybe Bruce is not ignorant of that, but his writing here doesn't include allusions or references to the work of guys like Gilbert Ling, who actually document that energy production is dependent upon water. That's Gerald Pollack, Gilbert Ling 101. And so this idea that it's all about ATP really reduces life to biochemistry. And life is not just about biochemistry, it's about energy as well, and energy equals light. everything he's talking about in this paper, and I don't want to go into too much detail about it because it's a big rabbit hole and kind of sideshow to this. Not sideshow, that's the wrong way of putting it. It's another story for another day. Let's just leave it at that. All of it comes back to light as well. And you could just write this paper the exact same way in the context of the energy that the human body, its cells, and mitochondria are absorbing. But in the meantime, ATP and oxidant production, this is how the biochemists think about it. And this is a really useful tool to understanding how our mitochondria are doing. Okay, while the gross age-related declines in respiratory complex activities have been reported extensively, much less attention has been given to the extent of age-related changes in their substrate binding affinities. Okay, now that may have been Greek to 90% of you. Don't worry, it's actually very simple. What this means is that there are age-related declines in the metabolic activity of mitochondria, their efficiency, how much power they can produce, how efficiently they can produce it. That's been reported on extensively. Much less attention has been given to the extent of age-related changes in their substrate binding affinities. This is actually really important. Why is it important? Because later on, he's going to go over how you can give a massive dose of a B vitamin to accelerate an enzyme's function that isn't found in a way that's not done or happens in nature in order to get a functional outcome. In other words, you give someone a high dose of a B vitamin, you can overcome the age-related decay of that enzyme. And inherent to that, I want you guys to understand that as you get older, your enzymes, all of your cellular machinery gets less and less and less and less efficient. That's part of the aging process because as you age, mutations accumulate. And that's what aging really is, according to this model, right? So, when I finish this thought, a kinetic analysis of complex 3 revealed a significant 29% age-associated increase in the KM, decreased binding, for ubiquinone type 2. What does that mean? Okay, because this is just one example. It means that up to a third of complex 3 activity, and it doesn't really matter if it's complex 3 or some other enzyme or some other enzyme system, complex 3 activity can drop by 30% as you age. That is actually a really important take home because it could be true for any enzyme system. Now, again, Adobe Acrobat has quit on me. It's doing this like every week now, which I hate and despise. If you work for Adobe Acrobat, I would love it if you guys could produce a product that's good enough for me to want to keep using it instead of wishing that I had something that I could bail on it in favor of. But I digress. Where were we? 1 second, guys. Okay. And we're back. Okay. All right. The importance of optimizing metabolic function to prevent mitochondrial decay is illustrated by feeding the mitochondrial metabolites acetylcarnitine. Excuse me, Toby, you're not acting right. The importance of optimizing metabolic function to prevent mitochondrial decay is illustrated by feeding the mitochondrial metabolites acetyl-L-carnitine and alpha-lipoic acid to old rats, okay? So I'm going to save you guys the long version of this, but basically feeding rats these two nutrients has been shown to reduce their age-associated decay and declines in mitochondrial function. So brain function declines with age and is associated with diminishing mitochondrial integrity. Feeding ALC, alpha-lipoic acid, and acetyl-L-carnitine and lipoic acid to rats improves cognition and other functions. The activity/kinetics of the mitochondrial complexes were examined in the brains of young and old rats, as well as in old rats fed alpha-lipoic acid and acetyl-L-carnitine. The brain mitochondria of old rats compared with young rats had significantly decreased endogenous antioxidant and superoxide dismutase activity, with more oxidative damage to lipids and proteins and decreased activities of complexes 1, 4, and 5. What does that mean? It means that as these rats age, their enzymes work less well. As you give them these nutrients, you are going to restore their function, as they say in the next part. So feeding this combo to old rats partially restored age-associated mitochondrial dysfunction to the levels of the young rats, though clearly not through changing the binding affinities. These results indicate that oxidative mitochondrial decay plays an important role in brain aging, and that a combination of nutrients targeting mitochondria could ameliorate mitochondrial decay, perhaps through preventing mitochondrial oxidative damage and enhancing mitochondrial biogenesis, right? Long story short here, nutrients can have a very profound effect on how your cellular machinery is working, which is why I am never surprised when somebody comes back to me having started a nutritional supplementation protocol that I've recommended to them based on, particularly on labs, but sometimes just without even any kind of lab data, and they say, I feel so much better, right? Now, there's a lot of negativity and hate and let's say disdain for what I do in the conventional medical world, because they say, well, they're just making this up as they go along. There's a very firm foundation for this in the literature. The reality is it has not been translated, we would call it bench to bedside, for care to the level of evidence that the conventional doctors would like to see, which is sad, but also a reality, and also doesn't mean that we should not do it, because it obviously works once you dial in protocols and you understand the background information, right? And that's why we can get such consistent results when we take care of patients with an eye to exactly what they're eating, how much they're eating of it, and how they're preparing it, which is what we cover with people in my medical practice and in my wellness coaching practice at stillmanwellness.com. But anyway, that's another story. All right. The neuronal mitochondrial ultrastructural changes of young and old rats supplemented with ALC and LA were analyzed using electron microscopy techniques. Controls displayed an age-associated significant decrease in the number of intact mitochondria, as well as an increase in mitochondria with broken cristae in the hippocampus, as demonstrated by electron microscopic observations. Translation: when you give the aging rats these nutrients, their mitochondria and their neurons are less broken and they work better. I won't go belabor that. It's pretty simple here, and they spell it out pretty well. So let's go back up. Actually, we need to scrolling. Perfect. Okay. So one thing that I want to highlight here is something that he says that I think a lot of people would gloss over, because it ended up being a big or much bigger part of my practice than I ever thought it would be at the outset, which is that one possible mechanism of mitochondrial decay is that with age, stiffer membranes due to lipid oxidation or increased oxidative damage to mitochondrial proteins causes structural deformation of key enzymes such as carnitine acyltransferase that lowers their affinity for the substrate enzyme. Translation: a possible mechanism of your mitochondria getting old and therefore you developing degenerative diseases that go along with mitochondrial decay and aging is stiffer membranes. What makes your membranes of your cells and their organelles stiff? Lipid oxidation or peroxidation, or increased oxidative damage to the mitochondrial proteins that then cause those proteins to not work as well. The best analogy that I have for you for this is rust, right? When you rust something, it doesn't work as well, and if you rust it enough, it won't work at all. It doesn't matter if it's a doorknob, a lock, a pulley mechanism for something that you're hoisting. It doesn't matter if it's the wheels on your car or the wheels that allow your kitchen drawers to open. If you introduce rust to a mechanical system, it is not as efficient. And your mitochondria, your membranes, your enzymes, all these things that make you you and make you function and make you robust and resilient and healthy, as they take more and more and more damage, what you're seeing is essentially them becoming rustier and rustier and rustier. And it takes more and more effort. Think of it as WD-40, right? In order to get the process to go with the same amount of effort that it caused or required before. This is a process that I see patients struggling with as they go through the aging process. They say, why is it that now I have to take more of this to feel the same as I did when I was 20 or 25 or 30 or 35 or 40, such as, let's say, caffeine or a stimulant, a pharmaceutical drug, a nutrient, whatever. They don't realize that their fundamental machinery is declining in quality. And so they need a higher dose of everything in order to get the same response. What this also means is that they will tolerate less stress and less wear and tear, and lower stresses or lower amounts of stress and toxic load, toxic burden will cause a disproportionate increase in impairment. You've all experienced this as you've aged, unless you're still really young. This is the 30-year-old who says, boy, I cannot have more than 3 or 4 drinks now without feeling like I'm going to die the next day. What happened to the metabolism I had at 20 where I could crush a 6-pack on a weeknight in college and not bat an eye the next morning and go to class, right? This is a really important concept because the name of the game for preventing aging, arguably based on this model, is for us to minimize the amount of long-term chronic insidious damage that's taking place to these structures so that the machinery itself, as it's being coded for in our genomics or genetics, comes out as squeaky clean as possible when we're older, okay? That's also, by the way, what Bruce is talking about with optimizing nutritional inputs. He's talking about how do we use nutrition to prevent the damage to the body that is synonymous with aging and decay. It's a really important point that must be made, okay? Feeding old rats the substrates, ALC with LA, the nutrients I talked about before, for a few weeks decreases oxidative damage, allowing the synthesis of new carnitine acetyltransferase with normal binding affinity. Why is this so important? This is super important because oftentimes we'll see that people get disproportionately better results within a matter of weeks rather than a matter of days or hours. Yes, we can give nutrients and have immediate effects. Those are often very impressive, very encouraging. Thank you, by the way, for the likes, the love, the shares, all that stuff. I see you guys doing that live, and I really appreciate it. Your comments also help. I like to say send this to someone who you think needs to hear it, even if they don't want to. Actually, especially if they don't want to. But anyway, why is this point that I've just made super important, right? I'm going to repeat it. Feeding old rats the substrate ALC with LA for a few weeks decreases oxidative damage, allowing the synthesis of new carnitine acetyltransferase with normal binding affinity. So if something's happened to impair the efficiency of a system in your body, giving the nutrient that restores that system can then lead that system to come back as if the damage had not happened, okay? That's really critical because a lot of people get stuck in thinking, well, the problems I have today are just inherent in the aging process. And I'm here to tell you, having seen many, many people over the years, patients of mine, friends, family, whoever, sometimes completely independently of my helping them or working with them, reinvent their health by embracing the principles that I try to communicate and teach in my social media, in my videos, on my blog, okay? Because what happens is when you nourish the body properly, it's able to do things the way it would anyway at a younger age, but can't because of a lack of nutrients. That isn't to say that nutrition is going to reverse aging, but that there's a argument to be made that it could do exactly that. Okay, triage theory, what I wanted to talk about all along. But why did I not start by talking about it? Not only because Bruce didn't start his paper with it, right? But he wanted to walk you through the rationale behind why this might work based on really impressive changes we've seen with just 2 nutrients, lipoic acid and carnitine, okay? So the triage theory provides a unifying rationale for a causal link between deficiency of a micronutrient and the many degenerative diseases accompanying aging, such as, I'm not going to list them, but all the diseases you don't want. Now, what does he mean by micronutrient? Essential minerals, vitamins, amino acids, and fatty acids. These are the top 4, I would say, things that I see patients making critical mistakes in with regards to their nutrition. They're not getting enough of them. They're not getting them in the right ratios. Sometimes there's a big problem, like say a toxic exposure. Many people in the nutrition world don't talk about this, don't think about it, but things like heavy metals compete with all these nutrients, right? Things like hydrogenated oils compete with the essential fatty acids, omega-3s, omega-6s, and saturated fats, okay? With the amino acids, right, for all we know, some of the food additives we have could be similar in structure to those and could interfere with or change their metabolism or their absorption, right? So there's lots of interactions here, there's lots of nutrients, but it's actually a pretty short cast of characters that really does most of the heavy lifting behind, well, I would say within this paradigm, okay? And I like to say, and Jim Laird taught me this, small hinges swing big doors. That's certainly the case in nutrition. These micronutrients can absolutely move the needle for people, and I'm so impressed by the results I get in my practice when I start to use these in the proper doses in the right person, and I get them on the right diet that's going to be rich in them. But anyway, okay? These diseases might be delayed by an inexpensive micronutrient intervention. He's coming out right out and saying it. Micronutrients are cheap. It would be easy for us to improve the health of the average person and certainly of the public in general if we were to use these judiciously in our medical care, right? But also on sort of a grander scheme or scale, like such as might be a public health initiative. Not that I want those people to have any more power than they already have, and would in fact prefer that they have less. But that's another story for another day. Okay, triage theory posits that when a micronutrient is inadequate, nature selects for a rebalancing of metabolism that ensures survival of the organism at the expense of metabolism whose lack has only longer-term consequences. What does that mean? Okay, so what it means, and I explain this sometimes to patients in terms of water. So water is an essential nutrient. You must have water or you will die. If you were to do an experiment where you were only to have 2 liters of water a day, max, all you had was 2 liters. You couldn't flush your toilet except with those 2 liters. You couldn't take a shower except with those 2 liters. You couldn't drink water except out of that 2-liter allowance. You couldn't cook without that 2 liters. If I gave you only 2 liters of water a day, you would not die of dehydration, but you would be smelly, you would be cranky, and you might end up with serious hygiene problems. Not to be too graphic about it. And you understand this intrinsically, right? So what would you do if I only gave you 2 liters of water? Well, hopefully you would drink all of it, because generally speaking, it's not possible to live on less than that. As a matter of fact, we in the hospital, doctors will limit patients who have problems handling their fluids, if they have heart failure, kidney failure, something like that, to less than 2 liters of fluids a day. And that, generally speaking, is what you're going to find is essential for people to live. You can go lower than that, but boy, do a lot of metabolic processes suffer when you do that. And that's exactly my point, okay? So you can have a tiny amount of water to live, but if you think of all the other things that water allows you to do and do well, you sure care about going from 2 liters at minimum up to 5, 10, 20, 30 gallons a day, whatever your intake is between bathing, hygiene, cooking, cleaning, drinking, whatever it is, right? So this is just the same as with every micronutrient and every nutrient, frankly, that there is under the sun. Okay? So the critical thing for you to understand is that what the body will do when it faces a shortage of a nutrient is it will downregulate all the processes that are important for long-term survival and maintain only the ones that are critical, just like you would with water, right? So if you die of dehydration, you die. It doesn't matter if you're clean. It doesn't matter if you've been able to flush your toilet. It doesn't matter if you've been able to wash your clothes or cook food with water in it or whatever. You need to primarily use that water to hydrate. And the body does the same thing with all these vitamins, minerals, nutrients, amino acids, etc. Right? It will say, okay, we absolutely need this vitamin K to, let's say, cause our blood to clot if we bleed. And if we don't have blood clotting as a function of vitamin K, the body will die because of bleeding to death, right? There's a lot of vitamin K dependent pathways, though, that do all kinds of important things that don't have anything to do with clotting. When the body has enough vitamin K, it will run all of them. When it only has enough vitamin K for clotting, it will only run clotting. Those pathways that it downregulates are critical for long-term health, survival, and what we would call optimal health. And that's why there's such a big range in terms of the vitamin or mineral, amino acid, fatty acid content of your diet, from what you absolutely need to what's optimal, right? And sometimes I'll make recommendations to people that they need to have many times what's recommended, to the average person in their diet for them to live and feel their best. I don't think that this is that controversial. The reality is that micronutrient shortages over our history as a species are very common. The 15 essential minerals, as one example, are not distributed evenly on Earth. Dietary sources and availability of these also fluctuate markedly. And this has never been more true, I would argue, than in the modern age, because historically, people are limited to a local seasonal diet. Technology allows us to innovate around seasonality and eat the same diet that has nothing necessarily to do with where we live. So an example of that is you could eat nothing but bananas and vegan protein powder in Barrow, Alaska. but that might not necessarily be the right diet for you in that environment, right? And likewise, you could eat nothing but, I mean, you could import elk and caribou to, I don't know, Costa Rica and be a carnivore and eat only these animals that are, living thousands and thousands of miles away from you in the Arctic tundra, right? So we're able to do really crazy things with nutrition in our modern world because we are no longer immersed in nature and we're not limited to a local seasonal diet. And for all the people out there who think, well, I want to eat this way, I want to eat that way, I got to tell you, taking care of tons of you people who've been through all the influencers and all the diets and all the testing, and you've spent so much money on biohacking and gadgets and gizmos and tests, and you come in with like a 30-page, 50-page, 100-page binder of your prior results and doctor's visits and all this other stuff. There are simple things that people tend to be missing that we find very quickly when we start to take care of them in what I do, where it's totally explained by this lack of understanding of context of our historical place on planet Earth. But anyway, the triage theory predicts that optimizing intake of the 40 essential micronutrients will reduce the risk of chronic diseases associated with aging and increased lifespan. Translation, if you get the amount of a nutrient that you need as a unique individual right, you should see chronic diseases minimized and you should see your lifespan go up. That's the theory, okay? So they did this great series of experiments on this, and I won't give you guys anything more than just kind of the cliff notes on this, on vitamin K. And I alluded to this earlier, right? So here's what they did. For 16 known vitamin K dependent proteins, we evaluated the relative lethality of 11 known mouse knockout mutants to categorize essentiality. What does that mean? It means that there are 16 known vitamin K dependent proteins. They wanted to see if you knock these proteins out at a genetic level, will you kill the organism? In other words, what functions of vitamin K are essential to be born and to live, period? Not necessarily live a long life, right? So results indicate that 5 vitamin K dependent proteins that are required for coagulation have critical functions. In other words, if you don't have these 5 vitamin K dependent proteins working, the mouse in this case will not be born. We can infer that's probably true about humans, although we would obviously never do this study because that would be grossly unethical. Okay. Whereas the knockouts of 5 less critical vitamin K dependent proteins, osteocalcin, matrix glycoprotein, growth arrest specific protein 6, transforming growth factor beta inducible protein, survived at least through weaning. What does that mean? It means that the animals that didn't have those extra vitamin K dependent proteins online still survived through weaning, okay? What that means is that you don't need all of your vitamin K dependent proteins to be running at 100% capacity to be alive or even to be born. But it implies that there's a significant effect on your lifespan and, more importantly, your health span and your likelihood of developing certain diseases over the course of your life linked to the amount of vitamin K you have. Okay, genetic loss of less critical vitamin K dependent proteins, dietary vitamin K inadequacy, human polymorphisms or mutations, and vitamin K deficiency induced by chronic anticoagulant use are all linked to age-associated conditions, including bone fragility after estrogen loss and arterial calcification linked to cardiovascular disease. What this means and what we can infer from it is the more vitamin K we have around, up to a point, we might surmise, the more we're going to decrease the likelihood of these bad outcomes. In other words, bone fragility, arterial calcification, and potentially much, much, much more. Okay. A triage perspective reinforces recommendations by some experts that much of the population, and particularly those using vitamin K antagonists, warfarin and coumadin, may not receive sufficient vitamin K for optimal function of vitamin K dependent proteins that are important to maintain long-term function. Translation, many people are not getting enough vitamin K. They're not dying of vitamin K deficiency, but for all we know, 5, 10, 20, 30, 40 years of life are being lost because they don't get enough vitamin K. And all of this is happening insidiously. There's no fire alarm going off. They don't notice a day-to-day difference in how they feel, but the changes are there underneath the surface. We hypothesize that 2 of the many insidious but measurable consequences of moderate micronutrient inadequacy are increased DNA damage future cancer, and mitochondrial decay. Okay, very important. Translation of that, you're going to see DNA damage, which is going to contribute to disease in and of itself, and mitochondrial decay, again, future disease. And it's interesting that they make a note of future cognitive dysfunction and accelerated brain aging. If I get 3 complaints in my practice every day, it's brain fog, fatigue, and I can't lose weight, or I don't look the way I want to look, followed sort of by I don't feel the way I want to feel, which is sort of the same as fatigue and brain fog for most of my people. Why is that so important? All of what I do with 90% of my complaints or people's complaints starting with those 3 things is try to optimize their metabolism based on these principles in order to improve their metabolism so that they feel better and get the results they're looking for. They have clearer mental function, better attention, they have better memory, they have more energy, et cetera, et cetera, et cetera. Okay. You know what? I'm not going to go into this. And we're going to go ahead and bypass that as well. Okay, this one is one that I actually really want to, one that I really want to get into with you guys, because I think it's so underappreciated by the vast majority of people, even those who arguably have a strong background in this field. So enzymes lose binding affinity for coenzymes and substrates with mutation or age, a strategy for remediation with high-dose vitamins. What does that mean? What's the translation of that? Enzymes lose binding affinity for coenzymes and substrates. That means that the enzymes that do the work of making you you and keeping you healthy and young, they lose their ability to bind to coenzymes and substrates like B vitamins and minerals as they mutate, i.e. get rusty due to excessive oxidative stress, or age, same difference. And that we can overcome this effect with high-dose B vitamins. So a review showed that about 50 human genetic diseases due to defective enzymes can be remedied or ameliorated by the administration of high doses of the vitamin component of the corresponding enzyme, coenzyme, which at least partially restores enzyme activity. Translation: let's say that you've got enzyme X, and enzyme X works with vitamin Y. If enzyme X is not working very well, and you know that it's not working very well, you can give bigger and bigger and bigger doses of vitamin Y in order to overcome that inhibition. Just like if you have a rusty doorknob, a rusty pulley, a rusty lever, a rusty whatever, you can spray WD-40 on it, and all of a sudden, the same amount of energy that had you going nowhere in activating that thing, opening that door, activating that pulley system, that same amount of energy is getting you the same results you got last year or the year before that or 10 years ago when that thing wasn't rusted, same amount of effort, right? Enzymes grease the wheels of metabolism. You might look at it that way. Just came up with that. I kind of like it. I think I'm going to keep that one. Okay. Up to a quarter of mutations in a gene result in the corresponding enzyme having a decreased binding constant for a coenzyme, resulting in a lower rate of reaction. Translation: the more mutations your genes get, the more mutations your cellular machinery accumulate, the less well they work. The name of the game in staying healthy and young, let alone reversing problems that you have, comes back to making sure that the mutation rate is as low as possible, which doesn't mean making free radical generation 0. That's a long story for another day. It means you want to optimize your metabolic efficiency, which means targeted nutritional supplementation to optimize your metabolic pathways. Okay. The review points out that many of the B vitamins given at levels 10 to 100 times the RDA can raise coenzyme activity levels by an order of magnitude or more. Translation: when we give B enzymes at 10 to 100 times the RDA, in other words, the recommended daily allowance, we can raise the activity of the enzyme system massively, right? We've known this for a long time. Anecdotally, if you give patients megadoses of vitamins, they will tell you absolutely that they have profound physiological effects with both subjective, in other words, the patient perceives it, but it's not documentable, as well as objective. We'll see actual changes in things like heart rate, blood pressure, speed of cognition, memory, whatever. There's no doubt about that. It's very well established in the nutritional literature, right? But we're giving these huge doses. And people often give pushback when you say, hey, you need 1,000 times the RDA of B6. They say, what on earth is wrong with me? Why would I need 1,000 times the RDA? Well, you've aged due to either just the inevitable process of aging, or due to stress or nutritional deficiencies or toxins you've been exposed to or other life events that have caused you to accelerate the aging process, right? And by giving you a higher dose of this nutrient than you might need in order to survive, right? Go back to the water analogy and how I explained how that works. We may get a therapeutic effect where there's no downside, essentially. And the downside is a really important topic that we'll probably have to tackle another day. This review raises the issue of whether some appreciable percentage of the population may require a higher level of a particular vitamin or substrate for optimum function. And this is part of why the older someone gets and the sicker they become, the more confident I am that I can help them feel better, because the more likely they are to have a whole litany, a whole wide range of nutritional deficiencies that I can easily detect and readily remedy. Now, there's plenty of caveats to that. Got plenty of cases in my history where I'm like, man, I just wish that I'd been able to do this or that, or if the patient had done this or that, when people give me pushback on things I recommend to them, but nobody bats 1,000, even me. A follow-up review points out that it is common for proteins to become deformed with age by membrane, e.g. by membrane proteins, okay? If membranes become stiffer by oxidation, particularly in mitochondria. I'm going to read that again. A follow-up review points out that it is common for proteins to become deformed with age, e.g. by membrane proteins, if membranes become stiffer by oxidation, particularly in mitochondria. So what this basically means, oh no, I lost my place. It's very frustrating. All right, what does that mean? So it means that as your cells and their membranes age, it's going to have an effect on all the other cellular machinery, right? So one of the things I pay very close attention to is the composition of the cell membrane. Cell membranes are made up of some things that you make, like cholesterol, which is why I'm not a fan of manipulating cholesterol with drugs, as most of my colleagues are, as well as the composition in the diet of omega-6, omega-3, and saturated fats. The narrative around optimal dosing of omega-6, 3, and saturated fatty acids is mostly geared towards people who are committing the very normal sin or error of consuming massive quantities of highly refined omega-6s and partially hydrogenated oils because they eat processed food. I will tell you, as a doctor who takes care of people who are hyper focused on their wellness and taking a lot of supplements and listening to a lot of great advice out there in the health and wellness space, that if you actually test levels of membranes in the human body, in real people, you will see that people are over supplementing or under supplementing or over consuming or under consuming every kind of fatty acid. Why is that important? Why am I wasting my time, or spending my time, I should say, explaining this to you in so much detail? Because people think that the cell membrane is not important. It is. People take for granted that they're deficient in this omega-3 or this omega-6, or they have too much of this omega-6 or this much omega-3. And I will tell you that that is not true. You will find in real people that there are people who've massively over-supplemented or over-consumed omega-3s. You'll also find that there's people who are under-consuming things like omega-6s. And there's plenty of people out there, as the dominant narrative right now would tell you, who are over-consuming omega-6s, right? The reason that's so important is that a lot of people don't ever pay any attention to this, and they're just looking at levels of nutrients in the blood or in their diet, and they don't realize that they're making a big mistake in terms of their cell membrane composition, right? Which affects how all these other nutrients interact and behave. It would be a little bit like worrying about all of the appliances and finishes in your home when you have gaping holes in your walls or mold is eating through the drywall. Big mistake that I see a lot of people making. That is, as I've mentioned before, commented on in the literature abundantly. Okay, so we're almost done. In conclusion, most of the world's population, including that of the US, is inadequate in one or more micronutrients according to current intake recommendations. Nothing controversial there. That's 100% true across the board. Yet because there is no overt pathology associated with these levels of deficiency, there has been little public concern. This is a big, big, big problem. And all the idiots out there screaming at the general public about the importance of things that are considered to be essential to public health, who are not paying attention to nutrition, those people are hopelessly lost as to what actually matters for optimizing the function of the human body, mind, spirit, however you want to divvy it up, let alone preventing illness, disease, in general. I mean, really amazing to see how completely out to lunch a huge proportion of the experts out there are on this. And that's why we pay so much attention in my practice to nutritional deficiencies, because the number of people I see who are not getting enough of basic nutrients is amazing. And we really help them figure out why they're not getting enough. We help them figure out how to eat to get enough, so they don't have to just be totally reliant on supplements. And then we use supplements judiciously in order to help people remediate or mitigate or resolve nutritional deficiencies that we've documented. The triage hypothesis framework may facilitate the discovery of sensitive and specific biomarkers of micronutrient insufficiencies that can be used to optimize metabolism at a personal and population level. Really exciting what we can do with nutritional medicine. I like Bruce Ames, but I don't think Bruce Ames has talked to enough people like me who are already doing this. I can tailor nutritional supplementation to any patient with a combination of tests. It is very, from my perspective, the results are very reproducible. And that's why we bother to do nutritional testing in my practice, rather than just putting everyone on this and that and the other nutrient that we think everyone's deficient in, and then telling them to go out and eat a whole food, nutrient-dense, mineral-dense, vitamin-dense diet. Okay, you can tailor this to people. And for the record, you will get disproportionately good results, exponentially better results, if you go to higher doses of certain nutrients in certain contexts, which is something that I cover a lot in my behind-the-scene webinars, which you get access to only by subscribing to the email list at stillmanwellness.com, which you should sign up for. Link is in the description of this video. But anyway, oh, I lost my place again because Adobe is being dumb. Okay, more attention to balanced diets and optimizing micronutrients could have a major effect on delaying the degenerative diseases of aging. Couldn't agree more. Though a cautionary note is that too much of some micronutrients, such as iron or selenium, as well as too little, can be harmful. I could not agree more with this statement. It's part of why I make so much content. I've got so many videos out there on how people are overusing this and overusing that, and they're being fear-mongered and taking this and that when they don't really need it. I share a lot of behind-the-scenes information on this in my protocols with premium subscribers to my Substack. Again, that's stillmanmd.substack.com. And I try to help you guys understand this when you're working with me, either in a group coaching program or one-on-one in a medical program, so that you guys actually make the right decisions about your nutrition and you don't unwittingly overdose yourself on things, which I've seen happen enough that it makes sense to test rather than guess as to what nutrients you need. And there's a lot more for me to talk about on that score, because I've seen people fail to get the results with haphazard random supplementation that they then got when they actually did testing and figured out what they truly needed, rather than just doing the shotgun approach of, I don't have enough nutrients, or I must not have enough nutrients, therefore I will take more and more and more and more. More does not always equal better. We often pair people's nutrient supplementation programs. Well, actually, to be fair, I think we almost always pair people's nutritional supplementation programs back. We make them smaller, we make them more efficient, and we get better results. So, as always, thank you for watching. Please like, comment, share, subscribe. Make sure you're on the list at stillmanwellness.com. Take care. Have a great day. Don't forget to get outside.